Om Sri Sai Ram. How are you all? Fine? Happy? Okay, get ready with your pen, pencil, scale, rubber, book and so on. We are coming to a very interesting topic of similarity of triangles. In continuation with what we have studied, let us just recall once. Firstly, we have studied about similar triangles, its conditions. Come on, anybody? What are the conditions of similar triangles? Yes? Two triangles are said to be similar if, see, let us call the two names, triangle ABC and triangle DEF. If they are similar under three conditions. One is angle. The three angles of one triangle equal to the corresponding angles of the other triangle. Then the two triangles are said to be similar. Another one, the three sides of one triangle are proportional to the three sides of the other. Then the two triangles are similar. And lastly, two sides and one angle of one triangle are equal to two sides and one angle of the other triangle. Then we say the two triangles are similar. So they are the conditions. A. Come on. What is A? Angle. Yes. What is yes? Side. S. Two side and included angle. That is important, you must note. Also, you have seen Thales theorem. When a line is drawn parallel to one of these sides. So, let us suppose ABC is a triangle. If a line is drawn, say called DE, parallel to one of the sides, it divides the other two sides proportionally. What does it mean? AD by DB is equal to AE by EC. When DE is drawn parallel to BC. So its converse also is true. Means what? If these segments are equal and proportional, then the two lines will be parallel. That is a converse. Okay, that is called basic proportionality theorem, also called as Thales theorem. We also studied about bisector of an angle of a triangle. So if a bisector is drawn, then the ratio of the sides, suppose ABC is a given triangle. Let us suppose AD is the bisector. And bisector means what? The two angles are equal. Then what do you have? This bisector divides the opposite side proportionally. Means AB by AC is equal to BD by DC. That is the meaning. If AD is a bisector, then you have AB by AC is equal to BD by DC. Okay. And also you have studied about similar triangles and its area. If the two triangles are similar, then the ratios of the corresponding sides, the ratio of their areas, suppose you have two triangles, say ABC and XYZ, or DEF or PQR, whatever you call. If they are similar, then the areas. So area of triangle ABC, by area of triangle DEF. So we have area of triangle ABC by area of triangle DEF will be equal to squares of the will be equal to the corresponding squares of the corresponding sides. Say AB square by DE square also equal to BC square by EF square. They are the corresponding sides, also equal to AC square by DF square. So that is the meaning. This is also a very important theorem, and we have worked out some problems also on this. Okay, and also we have seen AAA, SSS and SAS conditions for similarity of triangles, which I just now discussed. So these are things which I already studied. With this we will come to home assignments. So in the figure, ABC is a right angle triangle with A equal to 90 degrees. So this is 90 and C is 30. And if C is 30, this full is 90. What about this angle? This will be equal to 60. Is it not? And then naturally it will be 30. This will be 90. This will be 60. So you are asked to prove that triangle DAB is similar to triangle DCA is similar to triangle ACB. So first point, in triangle ABC, in triangle ABC, you are given with the how to find out ABC. ABC can be got by 180 minus this is 90 plus 30. So 180 minus 90 plus 30, that is 180 minus 120 equal to 60 degrees. So angle B becomes 60 degrees. First thing, that is in triangle ABC. Coming to triangle ADC. In triangle ADC, you are given with the 90 here, 30 here. So third angle becomes 60. 180 minus 90 plus 30. So 180 minus 120, that is equal to 60 degrees. So this becomes 60. And lastly, in triangle ADB, small triangle, in this you have DBA is equal to 60 degrees. Already got 60 degrees. Is it not? And the remaining angle is 30 degrees. So using this result, so now what do you find now? We found that the three angles of one triangle are equal to the corresponding angles of the second, are equal to the corresponding angle of the third. So as the three triangles, note down, are you taking down? Fast, come on. As the three triangles are equiangular, so angles are equal, corresponding angles are equal. We have triangle triangle DAB. Anyway, you can take, there is nothing wrong. Is similar to triangle DCA, similar to triangle ACB by AAA similarity. So this is possible by AAA, angle similarity. See here, these two corresponding angles, they are equal, so they are similar. That is the first answer. Taken down? Okay, coming to second one. If two similar triangles ABC and PQR, so these two are the triangles which are similar. If the altitudes, AD is one altitude and PS is another altitude, are in the ratio of 4:9. So this is 4, this becomes 9. Maybe multiples of 4, 4x and 9x you can take. Find the ratio of areas of triangle ABC and PQR. So given that AD by PS is 4 by 9, 4 by 9. So we know that AB by PQ, because the two triangles are similar, so you must write triangle ABC is similar to triangle PQR. If the two triangles are similar by the SSS property, the ratios of corresponding sides are equal. So AB by PQ is equal to BC by QR is equal to CA by PR is equal to AD by PS. So you are asked to find the ratio of areas. Therefore, area of triangle ABC by area of triangle PQR. So by the theorem of areas, what does it say? If the two triangles are similar, then the areas are proportional to the squares of the corresponding sides. So squares of corresponding sides means what? AB square by PQ square is equal to AD square. So AB square by, see, AB and PQ are corresponding sides. Don't confuse, write as it is. Other side is BC square by QR square, corresponding sides. So BC is here, QR is here. And lastly, AC square by PR square. And as we have seen in the previous class, it is also equal to the ratio of the altitudes, AD square by PS square. So also equal to AD square by PS square. What are they? They are nothing but altitudes. Because when all the sides are proportional, the altitude also must be proportional. That's all the answer. Okay. But you must know this property. If you know that property, you can work out. Okay. Taken down? So nice. We'll pass on to next question. If the ratio of areas of two similar triangles is 16:25, find the ratio of their corresponding sides. So let us suppose the two triangles, let triangle ABC areas are given. So area of two triangles ABC by area of triangle, say DEF or PQR, whatever you call, is equal to 16 by 25. So by theorem we know that they are the squares of the corresponding sides. So this will be equal to AB square by DE square, also equal to BC square by EF square, also equal to AC square by AC square by DF square. Is it not? So therefore, side ratio of sides, ratio of sides is equal to, see, AB square by DE square is 16 by 25. AB by DE is equal to square root of this, 4 by 5. It may be AB by DE, or it may be BC by EF, or AC by DF. So ratio of sides is equal to 4 by 5, because it is a root of that. Root of 16 is 4, root of 25 is 5. So it need not be AB by DE only, any sides you can take. Corresponding side you must take. That's all the homework. Okay. Now we will pass on to today's topic. So today's topic is very, very important, called Pythagoras theorem. Who was Pythagoras? Pythagoras was a Greek mathematician who discovered a very famous theorem. It's a world famous theorem called as Pythagoras theorem in connection with the right angle triangle. Okay, but this theorem was proved in India by a very famous mathematician called Baudhyan. And then Bhaskaracharya also gave another proof for that. He had given a big series of letters to his daughter, namely Lilavati. So when Lilavati, his only dearest daughter, lost her husband, she became desperate. Then Bhaskaracharya writes a series of letters to her based on Pythagoras theorem in Sanskrit. In India, even though it was discovered 200 years earlier to Pythagoras, there was no publicity. So publicity was not given, and therefore the name of Pythagoras only remained for that theorem. Okay. Now what does that theorem tells about? It tells about a right angle triangle. In a right angle triangle, square and the hypotenuse. So this is the hypotenuse. So AC square is equal to sum of the squares on the other two sides. Other two sides are AB and BC. So AC square is equal to AB square plus BC square. So here right angle triangle ABC is drawn. Come on, all of you draw it. And actually there are three sides which agree to this Pythagoras theorem called Pythagorean triplets. Like 3, 4, 5. And multiples of this 30, 40, 50 and so on. Next you have 12, 5, 13. Okay. And then 17, 15. And then 7. So like that we have got certain specific sides which are called as Pythagorean triplets, or which makes the sides of the right angle triangle. Now let us see the proof of this. First, you are given with the right angle triangle ABC in which angle B is 90 degrees. To prove, second step, AC square is equal to AB square plus BC square. Means what? Suppose this is say 3 centimeters. This is 4 centimeters. 3 square plus 4 square. How much? 9 plus 16, this becomes 5. So that is the meaning. For that, one construction you must make. From B, draw BD perpendicular to AC. From B, draw a perpendicular, not bisector. Okay. So that is the construction you must make. Using this, we have to prove the next step. So proof is BD perpendicular to AC. So just in the previous lesson we have seen, if a perpendicular is drawn to the opposite side, the two triangles are similar. What are the two triangles? First one is ADB. ADB is similar to ABC because there is a perpendicular. So second and third are similar. Similarly, if you take this triangle BDC and ABC, they are similar. Just now we have given a proof with the alpha and all. Is it not? I think all of you remember that. And therefore they are similar. So we have side in this first triangle, side AB by side AC. This is AC. So side AB is got because it is a perpendicular, side opposite to perpendicular AB, side opposite to the perpendicular of this big triangle, namely AC. So AB by AC is equal to AD by AB. And as we have seen last time, suppose you have this angle as 30 degrees here, this becomes 60 in this triangle. And in this triangle, if this is 30, this becomes 60. Naturally, this becomes 30. An example I gave. Need not be 30 only, can be 40, 50 also, no problem. Now you can see. So how do you got this result? Side opposite to equal angles you must take. So in this big triangle, namely ABC, the angle 90 degrees here, side AC is here. So that is how you got AC. This refers to ABC triangle. And in this triangle, side opposite to this, that is equal to AB. So AB by AC is equal to AD by AB. Already got AD. So that is the side opposite to this, is equal to side opposite to the other one, we get AB. So that is the first result. Coming to second. So if you cross multiply, what do you get? AB square is equal to AC into AD. So we have taken, I think this is 90 and there is 90. So take one angle as say 30 degrees here. This becomes 60 and this becomes 30 and this becomes 60 and this is 90. So side opposite to equal angles we have taken. So AB square is equal to AC into AD. In these two, the first result we got. Now coming to second result. See, second results that refer to BDC and ABC. So BDC is the small triangle, ABC is the big triangle. Angle side opposite to equal angles. So this is 90 degrees. Side opposite to that is BC. So BC is here. In big triangle, 90 degrees. Opposite side is AC. So BC by AC is equal to side opposite to the smallest triangle. Say this 30, opposite to that is DC. In this also smallest triangle is angle is 30, opposite to that BC. So DC by BC. Cross multiply, you get BC square is equal to AC into DC. So adding these two, what do you get? Adding 3 and 4, we have a very beautiful result. AB square plus BC square, left hand side you added, is equal to right hand side you have AC into AD, AC into DC. So AC common. What do you get inside? AD plus DC. What is AD plus DC? See, AD is here, DC is here. Add that. What it becomes? It becomes AC. So AC into AC, that is AC square. So you have a very beautiful result. It is called world famous Pythagoras theorem. Sum of the squares of any two sides of a right angle triangle is equal to square on the hypotenuse. That is Pythagoras theorem. So we have proved it in 4 steps. Okay. So I think all of you can noted it. Now we will pass on to some problems of this. This theorem is also known as Baudhyan theorem. And in those days, Vedic times, that is before Pythagoras, 800 BC, 200 years before Pythagoras. What is BC? Before Christ. What is AD? After death of Jesus. Is it not? So Pythagoras gave this proof. After him, before him only Baudhyan had given. In the Vedic times, they were preparing homakundas, which was rectangle in shape. Have you seen homas being performed? You have seen? Yeah. It has a length, breadth and depth also. That rectangular homakundas were prepared by the help of what are called Shulba Sutras. Shulba Sutras were there. And Shulba means knot. They used to take ropes of different knots. And they are preparing the homakundas. And now, but converse of Pythagoras theorem. In a triangle, if the square on one side is equal to sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. That means, if 5 square is equal to 3 square plus 4 square, square on one side, say 5 square, is equal to sum of the squares of other two sides, then angle becomes 90 degrees. That is the meaning. Okay? Angle becomes 90 degrees. That is what is called as Pythagoras theorem. And the sides which form this rectangle triangle are called Pythagorean triplets. Now, shall we go to some problems? So, it is from Vedic time only they are knowing this theorem, by the help of which they are preparing homakundas, which I was just now referring to. Now, let us work out some problems on this. In a rectangle triangle, the sides containing rectangle are of length 5 and 12. Find the length of the hypotenuse. So, what is hypotenuse? That is the longest side. Shall we call it as PQR? So, it is a rectangle triangle. Rectangle let one angle you can take it as Q. You are given that the sides are 5 and 12. What is the length of the hypotenuse they are asking? So, in triangle PQR, in triangle, any triangle you can take. Come on. What is the name of the hypotenuse? First. Yes, PR square. What are the squares on the other two sides? One is PQ, another is QR. So, this is by Pythagoras theorem. Or you can call it as Baudhyan theorem also. So here you are asked to find out the hypotenuse and the sides given to be PQ, how much? 12, QR 5. Name you can give anything, there is nothing wrong, okay? Even you can call it as ABC also, small a, small b, small c. So 12 square is 144, 5 square is 25, that is 169. So PR is equal to root of 169. That is plus or minus 13. But we don't take minus here because side cannot be minus. And therefore you can write hypotenuse is equal to, so length of the hypotenuse. Length of the hypotenuse is equal to 13 centimeters. That is called longest side. In a right angle triangle, opposite to the biggest angle. Biggest angle is 90, opposite to that is called hypotenuse. Can you remember it? Very nice. Shall we go to next sum? You take it down? Okay, we will pass on next sum. Find the length of a diagonal of a square of side 10 centimeters. So there is a square. I'll draw a rough figure. So the side is 10. What is the property of a square? All angles are 90 degrees, right? All sides are equal, right? Both the diagonals are equal, that bisect each other at right angles. So we will call, say, let us suppose ABCD is a square. They are asking length of the diagonal. Side of the square is given 10. So in triangle DAB, so you can write solution. In triangle DAB, angle DAB, why it is 90? Because in a square all the angles are equal. So what kind of triangle? Now what is the DB called? DB is called diagonal. Is it not? So you are asked to find the length of the diagonal. So how to find out? We call it as DB square is equal to, by Pythagoras theorem, AD square plus AB square. So DB square you have to find out. AD square is 10. AB square is 10. So this you have to give reason by Pythagoras theorem. Pythagoras. Note down. You take it down. Okay. So 10 square plus 10 square. What is 10 square? 100 plus 100. How much becomes? 200. So dB is equal to root of 200. I will write it as 2 into 100. That is 10 root 2. So much of centimeters. 10 root 2. Therefore, length of the question, length of diagonal. How many diagonals you will have? 2 diagonals. Both are equal, right? 10 root 2. What is the value of root 2? Root 2 is say 1.4 you can take. 10 into 1.42. That is 14.2 centimeters. This is enough. Okay. So that is the answer. 2 marks question. How many can do it without seeing book? Good. Very nice. Noted? Okay, we'll pass on to next problem. Equilateral triangle verified that 3 times the square on one side is equal to 4 times the square on its altitude. So you are given solution. Given that in triangle ABC, come on, all of you draw the triangle. It is called equilateral triangle. What is the speciality of the triangle? All the 3 sides are equal. And let us take it as 2A, 2A and 2A. In triangle ABC, AB is equal to BC is equal to AC is equal to, let it be 2A. 2A units, or you can say centimeters. Okay, or I'll write units only. You can take any centimeter or meter, anything. Now, if that is 2A, you are drawing in altitude. So, angle ADB becomes 90 degrees because you are drawn AD perpendicular to what? BC. Therefore, ADB becomes 90 degrees. So, what type of triangle you get? You get right angle triangle, and which means that this angle is 90 degrees. Now, what happens to BD? As it is altitude, what does it do? It is perpendicular to this and it divides the side. So, you have BD is equal to D, BD is equal to DC. DC is equal to A units. BD is equal to DC equal to A units. In triangle ABD, now you have got 2 sides here. One is 2A, another is A. You can find out AD, no? So, in triangle ABD is a right angle triangle. So, hypotenuse, what is the name of that? AB square is equal to AD square altitude plus half of the base BD square. That is by Pythagorean theorem, Pythagoras theorem. Always in geometry you have to give reason for all steps. Reasoning is very important in geometry. So, AB square is AB already done, 2A square. AD square they are asking, we have to find out AD square. Plus BD is A square. So, AD square becomes 2A whole square, that is 4A square minus this A square. It becomes 3A square. So, length of AD now the question is, verify that 3 times the square on one side. 3 times square on one side is equal to 4 times square of its altitudes. So, AD square is 3A square, AD becomes root of 3A. AD becomes root of 3A. So, 3 times the square of the sides, one side. So, therefore, 3 times square of sides is equal to Any side you can take. 3 into side is how much? 2a whole square. So 2a into 2a is 4a square. 3 into 4a square, that is 12a square. And then you have 4 times the square on the altitude. 4 times square on the altitude. Are you following it or not? You are following, right? Super. 4 into altitude, root 3a square. So 4 into 3a square, that is 12a square. So both are equal. Therefore, you can write this is also 12a square, this is also 2a square. So what do you get? Therefore, 3 times, hence the proof. No need of writing once again. 4 times the altitude. Okay, hence the proof. Hence the result or proof, you can write. You are asked to prove that 3 times this side square is equal to 4 times the altitude square. So both are equal. Hence the result. Okay, followed? So we took some right angle triangle. In that right angle triangle, as it equilateral triangle, 2a, 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 half of that is a. Found out the altitude first by Pythagoras theorem. Then we made a 4 times altitude, becomes 4 into root 3a, 12a square. 3 times the side, 3 into 2a whole square, becomes 12a square. Got it? Very nice. Now, we see the home assignment. The sides of a certain triangles are given below. Determine which of them is right angle. A 9 cm, B 16 cm, C 18 cm. Is it right angle or not? How do you test it? By Pythagoras theorem. Similarly, A is 7, B is 24, C is 25. You must check. A ladder is placed against a wall such that its top reaches up to a height of 4 meters to the wall. If the foot of the ladder is 3 meters away from the wall, find the length of the ladder. You try yourself. Okay? On the basis of Pythagoras theorem. And let us see who will come prepared for this. Now shall we see what Bhagwan Baba says? Bhagwan Baba Uvacha. What everyone should seek is the grace of God. So grace of God is very, very important. It is greater than all wealth of the world. You may have crores and crores of rupees, but if the grace of God is not there, it's all useless. Is it not? So let us all try to get the grace of God, right? Sai Ram. Thank you. Answer all the questions. Come prepared. Thank you.